On this video, we are focused on Plaxis 2D software on deep excavation activities, and we click model and fill the information for contour, and then click OK. After that, click borehole at the origin and add for fill top and bottom borehole for 3 layers. Click materials and for sand, loam, silt. After that, for concrete also. New material is for building, which is the material model is linear elastic and non-porous. Changing the color for the material and checking for the parameters and click OK. After that, edit for the sand, checking for the general information, checking for the parameters information, for the stiffness, for the strength, then for groundwater table interface, change to 0.7 and then click OK. For the silt hardening soil, checking for the general information, and for the parameters, changing for the stiffness, groundwater, and for the initial interface 0.8 and OK. For for the building, checking the general and then OK. Then for the head, put 23 meter. First layer is silt hardening soil, second is sand, and for the third is loam. Then click OK. Move to structure, create soil rectangle at the coordinate start from 118 then to 273 coordinate. Right click and set material to building. After that, create plate, the coordinate 40 to 14, and for the second plate is from 60 to 14. After that, create for the positive and negative interface for both sides of plate. After that, click the plate and click for materials. Choose for plate is diaphragm wall, then click OK. Set the material for both sides of plate and then click create line between the two plates. The function is for the concrete slab later. After that, we move to create line load. Create node to node anchor first, and with the embedded row, we create the node to node anchor for both sides. Same goes to the second layer. Create the node to node anchor and with the embedded beam row for both sides. After that, we choose for the material of the anchor. We apply for both sides of anchor for to set the material. And then we move to embedded row where the behavior we change to crop body and set to both sides of embedded row, and then set the material for the embedded beam row and choose crop body, and set the material each of the embedded row for both sides of the plate. After that, we create line load at the coordinate of start from 28 to 37, and then we move to set the material for the building. After that, we move to mesh section and then click for building, right click, click refine mesh, and then we generate mesh, click OK. After that, click for the view mesh. From the analysis, we can see the mesh is formed at the working load area, at the anchor, in the building existing area. Then we move to stage construction. Fast forward from this step, we click for every phase, starting for the phase 1, which is building, and setting the material, and then phase 2 for installation of walls and workload, and activated the negative and positive interface of the plate for both sides. And then click for the working load and change it to -15, and then for phase 3, first excavation, deactivate the first layer, following the another stage, and at this stage is adjusting the pre-stress to 500 for both sides. After that, we move to second excavation, which is the second layer is deactivated, and then we move to second anchor row. The process is same with the first anchor row, but the pre-stress is 1000 for both sides of the plate. And then for the phase 7 is final excavation, and deactivate for the third and fourth layer. Then move to flow condition, and then create water level to new water level. After that, right click, make it global, and move to stage construction, where we can see activate the fourth layer and set material to concrete. And then for the floor condition, we change water level to borehole, water level 1. Then for the third layer is we set for cluster dry and analysis. Run the analysis for this stage construction. And we can view calculation of this analysis and the result. As we can see in this model, there is every stage that mentioned from the initial phase to phase 8 is final situation, showing the deformation, the stresses. That's all for the video, and thank you.